All right, this mini lecture is on oxidation and reduction processes um, or reactions. Oxidation reduction is also called the energy equation because most oxidation reduction reactions uh, release electrons. Those electrons are used for work and then they are absorbed by another substance. Another name for oxidation reduction reactions is redox, and that's what I'll be calling them, redox equations. So on oxidation reduction, we have substances that undergo oxidation. And oxidation means loss of electrons. And we see this in when we eat food, we oxidize food, we convert that to energy that helps our bodies grow or move. Oxidation is a process. If we take a piece of iron, we set it outside in a moist environment, it rusts, and that's the conversion of iron metal off the periodic table, a solid, into iron ions, either 2 positive or 3 positive, plus the loss of 2 or 3 electrons. And so we see that combining with oxygen to form rust. So we see iron go from a metallic looking substance to an orange powder. That's oxidation. Anytime we have an oxidation reaction, you will see the substance on the reactant side and you'll see the loss of electrons on the product side. Now, reduction is a process in which a substance gains electrons. And so when we look at oxygen, well, the natural form of oxygen is O2. When this oxygen reacts with the iron, it becomes an ion. It becomes two oxygens. Each oxygen has a -2 charge. All right. So over here, the oxidation number for oxygen or oxidation state is 0, just like it is here. Any element in its standard form, uncombined, has an oxidation number or oxidation state equal to 0. And what this means is that it has all of its electrons. Oxidation numbers or states are a way of bookkeeping where the electrons are. Have they been transferred or have electrons been added? So iron in its natural state has an oxidation number 0. Oxygen in its natural state has an oxidation number of 0 as well. But what happens here is this oxygen gains 4 electrons total. Each oxygen gains 2 electrons, and that's what we show over here. 2 oxygens, individual oxygens with a -2 charge. So oxygen went from a 0 oxidation state to a -2 oxidation state. That's reduction. Iron, on the other hand, went from a 0 oxidation state to a 2 positive oxidation state, or a 3 positive, either way you want to think of that. And it underwent oxidation. Now here's the tricky part. The substance that undergoes oxidation is called the reducing agent. Now, if you think of it this way, an agent is someone who assists. The iron is assisting the reduction of the oxygen. The iron is assisting the reduction of the oxygen. The iron is giving up its electrons so that oxygen may receive those and be reduced. So that's why iron is a reducing agent, and oxygen is called an oxidizing agent. A substance that gains electrons and is reduced is called an oxidizing agent. It assists in the loss of electrons for iron. So oxidizing agents tend to be nonmetals. Talked about nonmetals. They have high Z effective charges, or they have more protons in the nucleus, so they can pull electrons off other elements more readily. Think of chlorine. Chlorine like to gain that extra electron to become isoelectronic with the noble gases. So the nonmetals tend to be oxidizing agents, like oxygen. And the reducing agents tend to be metals. Okay. So what I have here is called a half reaction. This is one half reaction. This is the oxidation half reaction. And this is called the reduction half reaction. So when we combine half reactions together, we will get the entire reaction. So let's do this. Let's look at, let's change this to be iron 3 positive with the loss of 3 electrons. All right. Now I'm going to combine these two half reactions to get the overall reaction between iron and oxygen. So before we do this, what we have to do is we have to make sure that we can account for all the electrons. So when we add two half reactions together, it must show a cancellation of the electrons. We can't have excess of electrons on the reactant or product side. So we're looking at these two reactions, and iron lost 3 electrons, and oxygen gained 4 electrons total. So we have to think about what number do 4 and 3 go into, and that would be 12. All right, so let's say we multiply this entire reaction by 4 then. Multiply the entire reaction by 4. So what we would get is 4 irons yields 4 iron 3 positive ions plus the loss of 12 electrons. All right, for this half reaction, the oxidation or the reduction half reaction, multiply this entire equation by 3. Is that going to work? Let's see. 3O2 plus 12 electrons yields 6O2 negatives. All right, so we know we've done this right because the 12 electrons here in the reduction half reaction cancel the 12 electrons in the oxidation half reaction. That's important. That has to be done if, when combining two half reactions, the free electrons must cancel each other out. So if we add these together, we get 4Fe plus 3O2 yields. Now let's look at this for a second. We know that when iron and oxygen combine, metal with a nonmetal, we get a compound that looks like this in this case. So to make this balanced, we need to put a 2 here. All right. So what happened was, is I looked at this ion and I looked at this ion, and I went back and thought about my ionic compounds. And we know that in both 3 and 2, 6 go into both of those numbers. So I need 2 irons and 3 oxygen. But we know we have a total of 4 iron on the product side and 6 oxygen on the product side. So we had to make the compound first and then add the coefficient of 2 to fix it. All right. So what I've just shown here is, again, the oxidation half reaction, the reduction half reaction. When we combine those together, we may have to multiply the entire reaction by a number, a coefficient, in this case 4 for the iron and 3 for the oxygen. How do we know what numbers to multiply by? We look at the free electrons and we look to see what number, or calculate which number do both of these numbers go into, which was 12. That's how we knew it was 4 for the iron and 3 for the oxygen. We multiply through, we add the two half reactions together. When we look on the product side, we're going to have to think about what compound is formed with iron and oxygen. Here it is. And then we know that the multiplier there is 2 to make it balanced. I hope this helps, and we'll continue on in the next series.